And I think most of the speakers are going to have to, or all the speakers will have to project their voices because, and everyone will have to be silent because we don't probably have a PA system today. But I'm assuming everybody in the back can hear me. So you'll have to forgive me. I think I'm just going to read these little opening remarks rather than having memorized them. My memorization usually comes in the evening after I drink my ava. So my name is Ed Johnston, and I'm coordinating this conference for the Association for Hawaiian Ava. Welcome to the conference. And we're calling this conference AVA in 2002. So research update, primarily research from College of Tropical Agriculture and Human Resources. We've got Dr. Vincent LeBeau, of course. We have Dr. Dennis McKenna. Later on today, we'll have a panel discussion with Dr. Gary Henderson from UC Davis and Dr. Tavana from National Tropical Botanical Garden. We're going to start out with...
Ed, I think you just pumped a button there.
Oh.
So.
Uh-oh. It must have been right over here, because that's...
Oh, okay, go ahead.
So I'll keep my remarks brief, because a lot of you are going to have to fly out of here at the end of the day, and we don't want to spill over too much past 4 o'clock. But the purpose of the conference is to present an update on current research on ava today. Ava has been back in cultivation in Hawaii for a number of years, so a certain familiarity with this plant is assumed. The important issue now facing those of us who grow ava, use it, and sell it is recent media attention, publicity on the possibility that some cabalactones might affect the human liver. I don't think we're really talking about the traditional beverage there. We're talking about cabalactones, and it's only it's something that some of the other speakers will be talking about. And again, it's not. It certainly isn't something that everybody believes, and that everybody thinks there's adequate evidence of. The mission of our Association for Hawaiian Ava is research, education, and preservation of the cultural and medicinal values associated with the ava plant. We are a 501c3, we're a nonprofit, and we've been in existence for about 4 years now. We're not a growers group or a group of farmers, we're just a board of directors. We have about 6 members on our board of directors. Jerry Konanui, who is the president, who's standing there in the back by Clifford's Ava Bowls. We have Dr. Jerry Ooka, who is a UH CTAR plant pathologist who's around here somewhere. Oh no, he went to the airport to pick up one of the speakers. We also have Noelani Whittington, who works in Kohala and is not here today. We have Genesis Leloy, who's also on our board of directors, who is not here, unfortunately, yet, but he will be later on. And we also have Joel McCleary, who lives most of the time on the East Coast, but has a large property on the island of Molokai where they grow ava, primarily for the kava bar in Waikiki called Hale Noa. So that's our board of directors. I'd like to thank our co-sponsors for today's conference. Both of them will be here later on, bringing the lunch. Barbara McKenzie and George Nijensen. They own Kulanaki'i Farm, which is a certified organic ava farm. And incidentally, they're going to be opening an ava bar on Front Street in Hilo near Cafe Pesto within the week, hopefully, serving fresh ava. They've been incredibly generous and supportive, both financially and also with putting together the lunch that's going to be delivered around noon today. I'd also like to thank, the University of Hawaii College of Tropical Agriculture and Human Resources. They've really come through, particularly our first speaker, Scott Nelson, who has helped put all of the mechanics of this together. And the meeting room is very, very nice, and one of the reasons we decided to have it here is that we can offer it free to you for for information purposes. And certainly with the crisis that CAVA is going through, or AVA, we need to update everybody as much as possible. So the first speaker, Scott Nelson, is a plant pathologist with the University of Hawaii College of Tropical Agriculture and Human Resources. He's been working with AVA for a number of years to help manage and overcome some of the diseases that presented themselves when AVA was brought back into wide cultivation. He is a native of Raleigh, North Carolina. He received his PhD in plant pathology from North Carolina State University in '92. Scott has served 10 years in teaching, research, and extension for pineapple, banana, ava, noni, coffee, and a wide range of other crops. Today he is going to give an update on current research activities that are going on at the University of Hawaii. So thank you, Scott.
Thank you, Ed. Thank you for coming. On behalf of the College of Tropical Agriculture and Human Resources, welcome to the AVA conference. And I just want to put a plug in for our NONI conference, which is coming in October. If you're interested in NONI, please email me at noni@hawaii.edu. A special email address just for that conference. Okay, enough about NONI. I am going to be presenting some information on our college research update. I'm basically speaking for Skip Bidhan Bender today. So Skip would be presenting this, but he can't make it today, just like he couldn't make it the last time. This will be the second time I'm...
That's a cheap shot.
Yeah, thank you. He's not here. If you have any questions, please feel free to stop me at any time. And you can all hear me back there, all right? Great. And if you're in the audience and you're a person that I'm speaking about, I know there are a couple of you here. I want you to help me because I'm talking about your research here. Thank you. Our first item is pesticide update. Mike Kawate, who's at UH Manoa, at the Manoa campus, he's looking at pesticide registration for several products for AVA. Roundup, Weathermax. This kava now is a vegetable, I guess, so you can use Roundup on your kava, apparently. So I wouldn't use it right on the kava. I would use it around the kava because it's quite sensitive. I'm blocking you, aren't I? You get over here. Thank you. The application must be with a shielded sprayer or wick to prevent drift injury. And EPA is considering adding kava to the root crop group, and this will speed future registration of other pesticides. But that's kind of strange using the word speed and EPA in the same sentence. We'll see how that goes. Any questions on that? Okay, we'll move on. Briefly on the kava liver controversy, which we'll get a lot more information later today. We have Amy Brown of CTAR, is leading a group of CTAR and Jonathan Burns School of Medicine scientists and physicians. They've submitted a proposal for funding on the effect of traditionally prepared kava beverages on liver function. The objective, as you can see there, is to evaluate the liver function for long-term regular kava drinkers from existing kava circles in the state and against non-kava drinkers from the same ethnic groups. So hopefully that will be funded and we'll be able to proceed with that type of human subject research that's needed. Regarding the kava liver controversy over the last year or so, Dr. Bidhan Bender has really performed a good job in disseminating information and coordinating what's known about this problem and controversy and disseminating it to people by emails and other methods. Dr. Tong and Narukar received a research grant to investigate the effects of specific cavalactones on liver tissue cell lines. Dr. Tong is here today, and he'll be talking about that in just a moment. Dr. Jerry Ooka is here. Jerry, will you please stand up? Had to go to the airport, okay. You can talk to him later. He's also with our college, he's on Kauai, and he has been cataloging accessions of kava, in other words, collecting kava plants in his greenhouse and trying to categorize them. He has 218 accessions at this point that have been logged, although many may be from the same ultimate source, as you can see there. The core of the collection is from the Kauai Branch Station 1966 collection. Another large segment is from Ed Johnston's Aaliyah Point Nursery collection, which I have out here in my greenhouse as well. Thanks to Ed, all those varieties are now still available to people who want to get them from me. They're disease-free, so you can talk to me later to get cuttings if you'd like. And then a third major section was from the National Tropical Botanical Garden. He has not done morphological characterizations yet or chemotyping of the accessions. He's just collecting them right now. He's also doing some disease resistance observations. There's an important disease, especially here on the Big Island, called shot hole. And his observations indicate that these other related genera of plants are not affected by the disease, such as Micropiper puberilum and Piper batal. That's not to be unexpected with plant pathogens. So this pathogen, which I'll talk about in just a moment, seems to be very specific to Ava. Piper witchmanii is very resistant. Isa is resistant, although not immune. And neither of those are Hawaiian-derived kavas, but they are resistant to the disease, which may give us some material to work with in the future through genetic engineering, perhaps, or some other method. He's also looking at the role of disease-suppressive compost on disease and the green controls for insects and nematodes. Green being environmentally friendly. Dr. Tong and Dragul will be presenting their information later. Klaus and CS are both here in the audience, sitting up front, and they have a nice presentation, I believe, that will follow mine. Kavika Winter and Will McClatchy are also in the house here. Please stand up. We can, there they are, right back there. Kavika and Will. Kavika's with Lyon Arboretum, Will's with the UH Manoa Botany Department. And they're, I believe they'll be talking about this later, or not, okay? You won't be talking about this, but you can reach them and talk to them about this later today. And that is cataloging of Hawaiian Ava experiences, collecting and growing all Hawaiian varieties at one site to compare them, and to confirm chemotypes of Hawaiian varieties. Is that an adequate description of what you're doing? Would you like to add to that? Close enough? Okay. They say close enough for government work. John Kunisaki and Yoneo Sagawa at CTAR are working with kava micropropagation as tissue culture. And to date, they have 3 varieties, Hawaiian varieties that have been cloned from buds in sterile media. This is important for maintaining disease-free stock, in my opinion. They will be transplanting to greenhouse conditions soon. They're already successful on their first clone. And they're preparing to publish the protocol on micropropagation of kava. That should be very interesting and useful for those of you who may have your own tissue culture labs. Dr. Bidhan Bender, Tong, and Pakiele Kaufusi, who's also here. Paki, please show yourself. Thank you. He's a graduate student with Dr. Bidhan Bender. And also Mel Jackson. Where's Mel? Mel's here. So we have a lot of people here today. Paki is also working on quantifying cabalactose by near-infrared spectroscopy. And there he is. I told him I'd keep this up for at least 2 minutes, so Paki, you want to give us a brief information about what you're doing?
Basically, in principle, it's pretty simple, but if you want to know the cavalectone concentration of your varieties, normally they do the chemical analysis as Mayor Jackson and Transplanting is doing. But what we are doing now, we wanted to look for a much more a cheaper way of determining the cavalectone concentration. Therefore, we decided to use the near-infrared spectrum in measuring it. And the way we do it in principle is pretty simple. You just shine the UV light and penetrate it through the cover powder, the one that you prepared. And through that penetration, it actually vibrate the cavalectone molecules inside.
Near infrared light.
Yeah, infrared light.
Not UV.
Yeah. No. Yeah, it's near infrared light. So, and then from that we correlate it with the, that information we correlate with the chemical analysis data that Mayor Jackson is actually did a lot of that part of this work. And we developed an equation on that one. And when you come out with your cover powder, we just scan it through the machine, and you will tell what concentration of cavalectone you have inside your cover powder. So in the near future, you will be won't pay too much to know the cavalectone concentration.
I think that's worth a little bit. Wow, yeah. Thank you very much. That's quite innovative. Did you think of that? Whose idea was it?
Actually,
Oh, that's quite innovative. That's Dr. Kong's idea. Okay. That's going to put some people out of business, though, these cavalectone testers, right?
Put Mayor Jackson out of business.
No, that's out of business. Oh, he's laughing still, though. He's speaking. All right, now this was Skip Bidhan Bender's ongoing test to look at cultural practices and their influence on cavalectone production and yield. With this experiment, it was a kind of a complex design, but it's basically done in a microplot situation where you have grow bags with these different treatments. So you've got the 2 varieties, 2 shade treatments, 2 fertility levels, and 2 pruning regimes. And I'll now be presenting briefly what they've discovered for one of their, or for recent data they've collected. They've developed this term called cavalectone patterns. They're not referring to this as chemotypes right now because the chemotype patterns can change or be different, I should say, among the different parts of the plant, apparently, comparing the roots, the stump, the leaves. So this term cavalectone patterns we've highlighted in red. There's the data. I'll just jump right to the conclusions now from this. And basically their conclusion is that the chemotypes do not change as the plant ages for a given part of the plant. But different parts of the plant have different cavalectone patterns. The leaves of different varieties are similar. The roots and the stumps are slightly different. In moiety stumps, shade decreased some cavalectones. So the word there is that sun, bright sun, I guess, will give you more cavalectones than shade. For some of the cavalectones. The shade had no effect on the cavalectones in the roots of Moi and Isa. Is that correct? Did I summarize that correct, Paki? Okay. As far as cavalectone yields are concerned, here's the table showing the data. And I believe there's a summary slide with text that's more easy for me to deal with than tabular data. But this is 12 months after transplanting into these grow bags. And this would be the cavalectone yield in terms of pounds per acre. This is not the root or stump yield, this is the cavalectone yield as a percentage of the total plant. Right? Okay. So it looks like that, let's go to the summary data. Neither shade nor fertility nor pruning affected the yield of fresh stumps and roots. That's interesting. So they go on to say that fresh stump weight and roots average about 7,300 pounds per acre of cavalactones 1 year after transplanting. The highest cavalactone yield is about 54 pounds per acre in full sun and 200 pounds per acre, at 200 pounds per acre of nitrogen, phosphorus, and potassium. 50% shade did not reduce total cavalactone yield per acre. Oh, did. Thank you. So why did I put the not in there? I don't know. Thank you for correcting that. Here's a table showing how the percentage of cavalactones, the content of as a per plant unit plant basis increases over time. And this is a months after transplanting a 5-month-old plant. It's the months are on the x-axis, so 0 to 12 months after transplanting a 5-month-old plant. And the percent cavalactones is shown on the y-axis from 0 up to 18% on this graph. And these different colored lines represent the different parts of the plant. And these two graphs are for one for Moi and one for Isa. Isa being the so-called 2-day kava, right, Vincent?
Let's go to 4-day kava.
A 4-day kava.
It's really bad.
It's really bad. It's not a very good drinking kava. Anyway, it looks like at about 6 months after transplanting, or about 11-month-old plant, considering the nursery stage, the cavalactones then begin to increase quite rapidly, and reaching so far a peak in their study anywhere from 12 to 18 months after planting. So that's pretty much consistent with what we've thought of before for kava, which means you should grow it for about 18 months, I guess, at least. And then after that, it probably levels off according to data we've seen before. So you shouldn't harvest your kava too early, in other words, before 12 to 18 months at least. They also were looking at transplanting versus direct planting. In other words, what's better to transplant young seedlings or young plants, or to just use stem cuttings and put them in the ground? And so what they had here, they tried some node cuttings. They had four 3-node stems versus 1 3-node stem. So here's a plant that had 1 3-node stem. Here it had 4 3-node stems. Basically showing you that the more stems you plant, the more plant material you're going to get, which makes sense to me also. Let's look at their, here's another table with data that they've summarized in text on the next slide, which I'd like to go to right away. Recommendations that they came up with are that direct planting of stems is easy to do. The best growth is with a 3 to 4 node stem, not an entire branch, from the mid to the lower part of the stem. The best growth is by removing the stem top about 2 weeks before harvesting the stem, forcing the buds to emerge from the nodes in the stem. You stimulate the buds to come out before you lay the stem in the ground. Is that clear? What that means? Okay. It's best to plant the stem pieces soon after harvesting. If you store them for too long, the growth is going to be significantly reduced. They want you to plant them flat, about 1/2 to 1 inch deep into the soil or medium. If you plant them vertically or slanted, it tends to reduce the growth based on their study. And disinfesting or disinfecting the stem pieces with 10% bleach did not improve growth. I think that would probably even damage kava. It's probably sensitive to that. Any questions so far? I'll be entering more familiar territory soon, which is my own work, and I'll be able to be more relaxed, because I'm not very familiar with the work that these people are doing, just presenting what they're doing. Okay, here's a comparison of Isa versus transplant versus stem piece. agent planting 5 months versus just cut. So you can see that transplanting the transplants, the plant got much taller. The shade didn't seem to make a difference than the stem pieces. The size, about the same. Let's see if they have recommendations or a summary of that. No, they don't. I think you'll have to ask Skip or email Skip if you want more information on that right there. I'm going to give you now an AVA pest and disease update. And it should take about another 7 minutes on this, and then if you have any brief questions, it'll be fine. These are the main disease problems that I think we have with AVA in Hawaii. Root knot nematodes. I've been doing some research on these. AVA dieback, Pythium root rot, and this shot hole disease. So I'm going to present a little bit of information on all of these areas that I've been working on over the last year. In general information, this is kind of striking. The first 7 months of this year, I think I've only had 3 requests from clients for any information about AVA diseases. And one of the guys is sitting back there in the back. So the interest in the plant has really gone down. Whereas I was getting numerous calls per week a couple of years ago, no one's calling now. However, from my experience, dieback continues to be a problem, especially in the drier areas. I'll show you in a moment what it does to the Kona side. So the people who are planting AVA in the Kona side of the island have a big problem with AVA dieback. It's drier, the plants are more stressed, and the young plants collapse quite rapidly over there. Whereas here on the Hilo side, where it's more shaded conditions and more moisture, dieback is having an impact, but not as big as an impact as it's having in the drier Kona side of the island. For example, I visited this farm in June of 2002. This is the leaf symptom. We're seeing mosaic and ring spot on these plants. And you can see how fast they're collapsing. Here's one that collapsed. Here's one that's in the process of collapsing. About 30% of his plants had this collapsing symptom. So just beware of that problem if you're going to grow kava on the Kona side, Kainiliu area, or Kaido Kona area too. As far as shot hole is concerned, I was interested in how long it takes for symptoms to appear. And that is referred to as the latent period of the disease in technical terms. So what I did was we took several varieties of kava that I was growing in my greenhouse. I took the potted plants out into the field and placed them into the canopy of a field where there was a severe epidemic of FOMA shot hole occurring. And fortunately we had some rain right after I put them into the canopy. And the conclusion was, on average, it took about 18 days after exposure to the inoculum or to the spores for the symptoms to occur. So it's quite a rapid disease. The generation time is about 18 days from one symptom to the other. So that gives you an idea of how fast the disease can multiply in a field. I didn't see any difference among the varieties in this test in how fast the symptoms appeared or how severely they were affected. Although under field situations there is some variation in expression of the disease.
What's the result of that as far as like on the root, that we decrease the volume of the root and so forth?
The question is, what's the effect of this foliar disease on the root mass? And it has a significant effect. In fact, some plants can die in the real wet areas. But any time that you're decreasing the photosynthetic area, I believe that you're affecting the size and quality of the roots. And I'll show you in a moment what this disease can do. We have a spray trial that we set up. Yes?
I've been working with Jay Ram's collection in that I marshalled a similar experiment, or it might be the same one. I haven't talked to enough people yet. But what I'm getting is I gathered 48 of the plants and pruned them all the way back, took off all the dead upper story, and now the regrowth, the shoots are just, it's going wild. They're regenerating. And my question is there any research to disease resistance with the second growth?
The second growth is as susceptible as the first growth to the disease. It's just a matter of the environment.
So,
Yeah, and it takes a while for the symptoms to show up. So you'll see the symptoms come. As soon as it gets a little bit wet and cool, you'll see that material also be affected just as hard, just as severely as the other material was. It's primarily a function of environment, in my opinion.
There might be production of phytoalexin, would it?
Phytoalexins,
In other words, it might develop resistance.
yeah, that's not from my experience, though. The question is, plants do produce chemicals called phytoalexins, which in Greek means plant warding off. It's kind of like it's analogous to an immune response in plants, and I don't see any evidence of that, although I have no data to indicate that phytoalexins are not being produced. The disease moves in cycles, and there's cycles of destruction and regrowth of these plants. So you're experiencing a regrowth stage of the plant. I isolated the pathogen. I wanted to find out what the identity of the organism is, because some of us are not expert mycologists, and we're going on our graduate school training on identifying these things. So I isolated it and I sent it off to England, and the result is that it's a Didymella species, which is the sexual stage of Phoma. So technically this disease is a Didymella leaf spot, which is the name of the fungus. So this is maybe not of great interest to controlling the disease, it's just more of an academic interest. Yes?
Is this any relationship to the macadamia shot hole?
Well, the symptoms are similar, but it's not the same pathogen. Did everyone hear that question? Yeah, the question was, is it the same disease as affects macadamia? The answer is no. We had a brief fungicide spray trial near Hakalau. We looked at Messenger, which is a new product, 2 triazole fungicides called Elite and Enable, and we had a control. And the data collection was percent defoliation. We had a couple of spray applications earlier this year. Unfortunately, I think due to interplot interference, and we were in a very low-lying area for the disease, so the farmer was willing to sacrifice this poor area for the trial. We also had a lot of AVA dieback in that plot, but we didn't get any meaningful results. But I can make a recommendation for fungicides in just a moment, based on this part of the field. You can see that there is some dying back of the stems, and that's not normal. That's not the normal dying back of the stems. That's caused by this disease, shot hole. However, this is primarily regrowth material and is protected by a triazole fungicide like Enable. So you can get a crop, you can protect the crop, although it is reduced in size. This is what this gentleman was referring to just a moment ago. This kind of regrowth near the bottom of the plant. You see all these dying stems. Well, when these stems emerge and start growing up, they're going to go through the same cycle of attack and defoliation caused by this fungus as the original stems. This was our spray plot area right here. You can see that we had a lot of dead plants, and these plants were presumably protected by the best fungicides. So in the presence of AVA dieback in a low-lying area where water collects, and next to plots that were not sprayed, it was still a devastating disease that was not able to be controlled by the fungicides. This part of the field received, this part of the experiment received more regular sprays, and you can see that, and they're up higher, not as wet, and you can see the difference. So some people claim this disease is not a big problem, but I think that in combination with certain factors, it's devastating. And it even attacks the wild plants. This is Chris Allen. I don't know if Chris is here now or not, but this is a large plant in the wild that's pretty much defoliated with a lot of stem lesions there. So I don't know about this plant. It's about a year ago, and I'd like to go back and see how it looks now, but I bet it's looking pretty bad.
Scott,
Yes.
our wild patches are being devastated. They're just wiping out.
Yep.
The farmer's just going after them.
Mr. John Cross there indicated that his wild patches are wiped out by this disease. And it's very sad, very, very sad in my opinion. But I do have a disease-free collection out here of all these varieties. It's probably the only disease-free collection on the island. Yes.
Why do you think this has recently occurred, or not existed in the wild in the past?
I believe the question is, why did this disease recently occur? We first saw it here, we saw it at your farm, I think, around 1999. It came here around 2000. Fungi have a way of adapting to their host, especially when the hosts are brought from the wild into cultivated situations. Epidemic situations are favored by large populations of plants of the same genotype. So I think it's a human thing that caused this. You start to grow more kava, bring it out of the forest. This fungus, which was here at a nuisance level, like it is in Pohnpei. You go to Pohnpei, you see the same fungus, but it's only a few lesions here and there. They're not growing large acreages of this crop. The genetics of fungi have a way of recombining to produce more virulent offspring, and that's what happened here as a result of human activity, in my opinion. I'm going to have to go through a little quickly now. This is nematodes, and we were funded here by the Hawaii County Research and Development Office for this work, and it's almost completed, and I'll present some of the conclusions here. But nematodes cause this galling of the root system. They cause a rotting on the inside, even can attack the stems here, and to cause a yellowing and drooping of the plants. Here we see a nematode's head. From 1999 to 2002, I've been looking at 17 varieties in greenhouse experiments for resistance to the root knot nematode, Meloidigon incognita. The result, unfortunately, is that no varieties show any significant resistance to the nematodes. And the population in the roots can easily range from 12 to 20,000 nematodes per gram of root. And that's just the egg stage. That's not including the adults or the juveniles. So it's a quite susceptible plant, and it's a quite serious problem. Now, my optometrist wanted me to put this on. He wanted more business. But John Cross's farm cooperated with me on this. Basically, I had two varieties, Mahakea and Moi, and percent cavalactone reduction due to nematodes. And it could get as high as about 1.5% reduction in cavalactones per unit of root. And so I developed a little economic model based on this with some assumptions. The assumption is 40,000 pounds of wet kava produced per acre. That's with good disease control. And about a 1.5% decrease in cavalactones versus no nematodes. And basically the bottom line was that I think you can lose about $40,000 per acre to the nematodes. Even and I think that's conservative. You can really lose a lot more than that. So I think the nematodes can have quite an impact on the cavalactones that you're trying to harvest. I think that's primarily due to the rot that occurs in the root. The roots are rotting out. I don't think the nematodes are eating the cavalactones. Because they're still as active. They're not any more relaxed than they were before. Okay, so data like this could be a good economic justification to try to control nematodes. Now, I just want to close by saying we have an AVA website now. We've been promising this for a few years, and we finally came through with it. Now that no one cares about it, but we have the information. Farmer's Bookshelf has all the AVA pests and diseases there on the internet. You can go see that. By the way, email me, and I'll send you the same information. You don't have to scribble all this down right now. You can email me at snelson@hawaii.edu. Also have two disease publications you can get on the internet. They're free publications with color photographs, one on Ava dieback and one on Ava root knot nematodes. And that's at that website address right there. And with that, that concludes my presentation. Thanks for your patience.
Sometimes again, so like that, if it's like carefully dried, say at a lower temperature, you might end up with that.
So what's this conversation going now? Can we,
I'm going to talk about.
oh, he's going to talk.
yeah,
Okay.
We'll hear it then.
Thank you. One more, and then we got to move.
And nematode control, what you're
Nematode control, well, you can do pre-plant fumigation or treatment. That's legal to do. Avoidance is a large one. That is to avoid planting cuttings into nematode-infested soil. Composting and organic material really helps to suppress. And chicken manure can suppress nematodes. I would say marigolds. Marigolds have anti-nematode effect. Avoidance and composting, I think, are the two things you can do. Well, yes.
Sun hemp?
Sun hemp is a green manure.
Control nematode?
That can have some nematode control, yes, by incorporating sun hemp foliage into the soil or growing sun hemp. If you have more questions, one more, okay.
Yeah, I just wanted to point out, I've been experimenting a while ago, but not to this level. It's turmeric. Rolena, Tumalanga, Tumarinolica, and I've been spraying on my Pharaoh light before, and that had some success. And then I've been experimenting with some of the varieties of olive over the years, and some of the varieties had some success, but I didn't do it on a large scale or legal documentation. But I think turmeric has natural possibilities being a natural fungicide.
Turmeric.
Oh yeah.
Okay, thank you. I'll have to search on that.
Okay, thank you, Scott.
You're welcome, thank you.
Let me point out that just before we break for lunch, we're going to have a little bit of time for some announcements, because I know there's a few folks in the audience that have a little bit of information regarding possibly future purchase of AVA, and one other thing which I'll think of closer to lunch. So our next presentation will be given by Dr. CS Tong and Mr. Klaus Dragel. CS Tong received his PhD in agricultural chemistry in '67 from the University of California at Davis and joined UH in '68. He is a professor in the Department of Molecular Biosciences and Bioengineering, teaching plant biochemistry and environmental biochemistry. His research centers on natural products in Hawaiian plants and phytoremediation.
Phytoremediation.
Klaus Dragel has a master's degree in agricultural.
Klaus Dragel.
Dragel, excuse me.